Welcome back to the Deep Dive. You know how we operate. We take a mountain of documents, research papers, and technical notes, and distill them down into the core knowledge you need.
That's the goal.
Today, we are strapping in for a serious deep dive into the engine room of modern AI, specifically agentic AI.
Right.
We're not talking about systems that just, generate text. We're talking about agents that can look at a problem, develop a plan, perform real-world tasks.
And this is the key part.
And most importantly, learn from their mistakes to get better. This ability to continuously self-improve is, well, it's the holy grail of automation.
And understanding how that improvement mechanism works, that's the mission for today. Our sources really zero in on the structural blueprint that enables this kind of dynamic learning.
The COREF loop.
Exactly, the COREF loop. It's described as this essential iterative process, a 5-step framework that ensures an AI agent doesn't just execute a function once.
But learns from it.
It learns from it. It iterates on its failures and its successes. It moves AI from being, I guess, a passive tool to an active, self-optimizing partner.
That structure is so vital, especially for you, our listener, if you need to understand the why behind reliable performance. This isn't magic, it's methodology.
It's engineering.
For those tracking the process, COREF stands for 5 distinct but interconnected stages. That's comprehend, orchestrate, respond, evaluate, and fine-tune.
It's essentially a continuous quality assurance cycle built right into the agent's brain.
Let's start at the beginning then. The C, comprehend. Why is the way an agent takes in information now so fundamentally different from how, say, traditional software processes an input?
Well, traditional software follows hard rules, if this, then that. Agentic AI is dealing with complex, often ambiguous human intent. The comprehend phase is where the agent first has to process and really understand the input.
Okay.
And that understanding goes far beyond simple keyword recognition. The agent reads the user's request, yes, but then it has to immediately establish context.
And where does that context come from?
Crucially, it's pulled from its entire universe of available information, what the sources call its knowledge databases.
So if I ask a traditional system, what is the capital of France? It just looks up the fact and spits it out.
Yeah.
But if I ask an agent, help me plan my trip to Paris, the comprehend phase is doing more.
So much more. It's not just registering plan, trip, and Paris.
Right.
It's behaving more like an investigative journalist. It's looking at your request and immediately cross-referencing it with internal documentation, maybe user preferences stored in its memory, historical interactions, policy guidelines. The works.
The goal being what?
The goal is to establish the true executable intent. If you ask for the weather in New York, the agent identifies the location, sure, but it also extracts the subtle weather requirements. Are you asking for today, the weekend, an average for the month? It has to define the scope of the mission.
That makes that initial phase much heavier lifting than we might assume.
Yeah.
It's transforming a loosely structured human sentence into a tightly structured, executable set of variables and goals.
Absolutely. The quality of the final output is entirely dependent on the rigor of this comprehend phase. If the agent misinterprets the goal here, the rest of the loop is, well, it's pointless.
Okay, so once that intention is crystal clear,
The agent can't just jump into execution. It needs a rigorous strategy, which brings us to the O orchestrate.
the orchestrate phase. So this is the strategic director, maybe the project manager for the task. It's where the agent decides how to achieve the goal that was set in comprehend.
Exactly.
For our listener who might be interacting with these agents in a business context, this is where efficiency is determined. But I have to ask, doesn't this planning stage, this orchestration, just add unnecessary latency? Why not move straight to action if the comprehension was so strong?
That's a great question, and it gets right to the heart of what separates a reliable agent from a reckless one. Orchestration is the critical bridge that ensures reliability over raw speed. This is where the agent plans its response or action by designing a specific workflow. And that workflow isn't arbitrary. It's based on the reasoning from the comprehend phase and, critically, the available tools it can use.
Tools like what?
Whether that's a database lookup, a mathematical computation, or even generating some text.
So if the agent needs to find the lowest airfare, it doesn't just randomly Google things. It actually plots a sequence of database queries.
Precisely. And the sources highlight the mechanism often used to structure this sequence, the chain of thought process, or COOC.
COOC.
We hear that term a lot.
We do. And it's essentially the agent's internal checklist and his rationale. Instead of just thinking find airfare, the COOC dictates something like, Step 1, identify travel dates from context. Step 2, Query 3, specific flight aggregators. Step 3, compare results based on price priority.
Step 4, format the top 3 options for the user.
You got it.
Now the true implication of chain of thought really clicks. It's not just an internal monologue for the AI, it's a transparency mechanism.
By forcing the agent to structure its reasoning and sequence its actions, you dramatically mitigate the risk of what we call hallucination, or, just jumping to an unsupported conclusion. The agent has to justify its path before it even takes it.
That's the key takeaway. In complex scenarios like synthesizing a market report or planning a multi-stage logistics task orchestrate, uses POPT to break the large problem down into verifiable sub-goals.
And if one part fails?
If a sub-goal is achieved, the agent moves on. If it fails, it knows exactly which part of the plan broke. This dramatically improves fault tolerance. It's the difference between a contractor showing up and saying, "I'll build your house," versus handing you a 50-page construction schedule.
I appreciate that construction analogy. Complexity requires structure. So now the agent has its comprehensive plan. We're moving from the strategy board to the execution field. We shift from thinking and planning to actual delivery with rows.
Respond. Respond is the execution phase. It's the payoff. The plan that was meticulously drawn up and orchestrated is now put into motion.
This is where things actually happen.
Right. This is where the agent executes the actions. And this often means interacting with the real world, querying an external service or an API.
Which is just a standardized way for systems to talk to each other, right?
Exactly, like requesting data from a live weather feed or a stock ticker.
So this is where the rubber meets the road. Using our weather example, the orchestrate phase told the agent which weather API to call and what parameters to use. The respond phase is the actual click of the button.
It's the sending of the request and the retrieval of the raw data.
Correct.
Yeah.
The agent calls the external service, gets the information, and then generates the final polished response for you, the user, with all the current details. This is the output you actually see on your screen.
And for many people, that's it. The interaction ends there. They got their answer, task complete.
For most systems, yes.
But the crucial distinction of agentic AI using COREF is that execution is only step 3 of 5. A good agent has to check its own work, because even a well-orchestrated plan can run into real-world issues.
Like API downtime or corrupted data. Exactly. Which immediately leads us to the crucial self-correction phases, starting with evaluate.
Evaluation is the agent's internal quality control department. In this phase, the agent assesses 2 things. First, was the output technically successful? Meaning, did the tools work? Did the data come back correctly?
The plumbing worked.
The plumbing worked. And second, and this is more important, did the output align with the desired outcome that was established way back in the comprehend phase?
That alignment check is key. It's not just checking for an API failure. It's asking, did I actually fulfill the user's intent?
Yes.
If I asked for flight prices for a family of 4 and the agent just returned a single price, the technical call might have been successful, but the alignment completely failed.
Exactly. The agent is running a kind of internal audit, comparing the delivered results against the initial parameters. If the weather data came back, but the location was wrong or the data was maybe too old, the agent logs that as a failure.
Even if the API technically returned a value.
Even then, for you, the listener, who depends on accurate, timely information, this step is the fail-safe. It's designed to flag or filter those subtle garbage responses that look right on the surface but are functionally useless.
So the agent is constantly grading its own homework. Now, if that homework gets a passing grade, that knowledge is still valuable, right? Even a success is a data point.
Absolutely.
And if it fails, that feedback is gold. This brings us to F fine-tune, which is where the long-term compounding intelligence of the agent is really built.
Fine-tune is the phase of systemic improvement, and it's what truly drives the agency in agentic AI. Based entirely on the detailed feedback from the evaluate stage, whether it was positive or negative, the AI uses this information to improve its performance model. This is where the system gets smarter about itself.
Let's dig into the technical side of this improvement a bit. How does that adjustment actually manifest internally? Are we talking about simply adding a data point to a memory file, or is it a deeper, more architectural change?
It's much deeper than just memory. It involves updating the agent's internal strategies and logic. For instance, if the evaluation showed that one specific weather API was slow or frequently errored out,
Which happens.
all the time, the fine-tune mechanism updates the internal routing protocols. It might adjust the priority weights, making the orchestrate phase of the next request bypass that unreliable service entirely. Or maybe you only use it as a last-ditch backup.
So the agent is essentially rewriting its own internal project management manual based on live performance reviews. If a tool proves inefficient, it gets demoted.
Precisely. And if a certain chain of thought sequence consistently led to a high-quality result, that sequence is reinforced. It's prioritized for similar future tasks.
And if it leads to an error,
If a sequence led to an error that was caught in the evaluate phase, the agent incorporates a constraint or an optimization into its planning policy to avoid that exact mistake next time. This continuous adjustment of its decision-making process is the real essence of self-optimization. It's the difference between memorizing a fact and learning a better way to think.
this expansion on fine-tune is critical because it highlights that the learning isn't just, data accretion, it's a strategic evolution. The agent's entire approach to problem solving is being optimized after every single interaction.
It's the engine of adaptation. It ensures that the agent becomes more efficient and more reliable over time, minimizing errors and maximizing the certainty of a good outcome.
Okay, let's synthesize this entire process now. We've gone from comprehending the deep intent of a task
Right.
through orchestrating a rigorous, verifiable plan using chain of thought to responding with execution, then immediately evaluating the success and alignment of that output.
And finally, fine-tuning the system's whole strategy for all future interactions.
The central thesis from the source material is that this COREF loop isn't a sequence with a definitive end. It's not a one-and-done thing.
That's absolutely right. The COREF loop is a continuous, dynamic process. It completely rejects the idea of static programming. Every single response is a data point that feeds directly back into the system's intelligence, creating a perpetual cycle of adaptation and improvement.
And that structure is fundamentally why these AI agents can handle real-world tasks that are messy, unpredictable, and require, well, learning on the job.
It's built for that.
And for you, the listener, understanding this structure matters intensely because this continuous iterative process is exactly how the industry achieves reliable, robust AI agent performance. The source material is clear. The integration of this loop is the implied goal for developing high-performance AI systems across every sector, from customer service to complex scientific research.
You know, what really stands out to me is the inherent architectural design here. If an AI agent's core mechanism is inherently built around the fundamental requirement to improve its performance.
With every single completed task.
With every task. Meaning every single action is an opportunity to refine its strategic logic. What does this imply for the future speed of AI learning and innovation compared to traditional fixed programming?
That's the question.
If the system is designed to accelerate its own competence almost exponentially, how fast will the rate of technological change truly become?
It changes the entire paradigm of iteration. We're used to waiting for software updates, version 2.0. These systems update themselves after every click. That's a profound thought to take away.
It really is.
Thank you for guiding us through the mechanics of agentic learning. That was a serious deep dive into the inner workings of AI adaptation. We'll catch you next time.